Okay, we've got rules about how to combine normal distributions when they're independent, and we're going to apply that here. We're just going to be dealing with the distributions, but we've got to be really careful with these rules about knowing when we've got a standard deviation and when we've got a variance. So for this x, okay, the mean is 10, so that's a mu equals 10. That's the easy one, okay? But this is a standard deviation, so this is sigma, which is 2. Okay, therefore, the variance, which I'm going to need to work with for the x, is sigma squared, which is 2 squared, which is 4. So x, if I write it in the alternative notation, is a normal distribution with a mean of 10 and a variance of 4. Okay, so when I get to y, all right, what they've given me is a mu, so mu is 25, and 9 is the variance. So sigma squared is 9, so sigma is the square root of 9, which is 3. Okay, so I've now got a really clear setup. I know the mean, the variance, and the standard deviation for each of x and y. So here I'm setting up x plus y. So the new mean is going to be dead easy. The new mean is just going to be the mean for x plus the mean for y. So the mean for x was 10, and the mean for y was this 25. So my mean is going to be 35. Okay, now the rule for adding two random variables, okay, works with variances, not with standard deviations. So it's the simplest rule at the top, okay. I've added the means, that's the normal thing to do. The variance, I need to add the variance of x to the variance of y, not the standard deviations. So therefore, okay, my new sigma squared for x plus y, is going to be the sigma squared for x, okay, which wasn't the 2, it's this 4, so it's the variance of x plus the variance of y. Let's write out the formula, which is the 4 plus the variance of y is this 9, not that 3. So 4 plus 9, which is 13. Okay, so therefore, x plus y, the random variable x plus y, has a normal distribution, mean 35, and variance 13. Okay, but the question asks me for the mean and standard deviation of each. So I've already stated the mean is 35, but let's write it here. Mu equals 35, and the standard deviation sigma is the square root of 13, which I can leave as a surd, which just means a square root, or I can do the square root of 13 on my calculator, and I can see it's 3.606. To 4 significant figures. Okay, so we're going to use a similar kind of pattern for the others. So for x minus y, okay, well, I've already got, I know that the expectation of x minus y is going to be expectation of x. Well, what I'm subtracting, here are the rules I can use. So I subtract the expectations, as you'd expect, means behave as you'd expect pretty much all the time. So the expectation of x minus the expectation of y, that means I'm going to be subtracting the means. So the expectation of x was the mean of x, which was 10, minus the expectation of y, which was 25. So this is going to be minus 15. That's all right. I can get negative values when I do a subtraction. Okay, and the variance of x minus y. So this is a tricky one. Variance doesn't always act the way you expect. When you subtract random variables, you add their variances. So the variance of x minus y, I actually have to add these two variances. So I need to do the variance of x plus the variance of y. Okay, and that is going to give me variance of x was this 4. Okay, variance of y was not that 3, it was that 9. So it's 4 plus 9, which is 13, same answer as last time. So therefore, x minus y, okay, the distribution of x minus y is normal with mean minus 15 and variance 13. I'm asked to state the mean and standard deviation. So the mean, I've already got, is minus 15, and the standard deviation is not the 13, it's the root 13, which is that same 3.606 number, if I want it as a decimal. But I'm going to move on. Okay, the next one is 2x minus 3y. Now, here we're multiplying a random variable by 2. Now, you actually did that in Stats 1. Last year, ages ago. You knew that when you scaled up data, then doubling will affect the mean in the normal way, and doubling the data will double the standard deviation. Not double the variance, double the standard deviation. So that means when I've got something times x, okay, I've got to be really careful Okay, mean works as you expect. Okay, if you're doing ax plus by or ax minus by, then you do a times the mean plus or minus b times the other mean. Fine. But with the variances, okay, if you've got a times x, okay, forget the by for the moment. If you've got a times x, the variance of that isn't a times the variance of x, it's a squared times the variance of x, yeah? That's because the standard deviation of x would get multiplied by a, but the variance is the square of that. So this rule for variances, when we've got a number times the random variable, introduces squares of those numbers. So you need to learn this rule, is the bottom line, okay? Notice that we've already seen when we subtract means, then we get a subtraction, when we subtract random variables, we get a subtraction of the means. But when we subtract random variables, the variances, okay, always get added. So this is not a misprint. That's a plus or minus, but this is always a plus regardless of whether we're plussing or minus. So we'll need to use that here, because for this one here, I've got the 2x minus 3y. So I'm going to do the expectation of 2x minus 3 minus 3y all in a bracket. Okay, so expectation of 2x minus 3y means work as you'd expect. So this is twice the expectation of x minus 3 times the expectation of y. So this is going to be 2 times, what's the expectation of x? Expectation of x was the mean of x, which is way back up here, which is 10. Okay, so it's 2 times 10 minus 3 times the mean of the y, and the mean of the y was 25. So this is 20 minus 75, which is minus 55. Okay, minus values are cool, don't mind that. They're not cool for variance, but I'm not going to get a minus to the variance, as you will see. So the variance of 2x minus 3y. Variances do not work how you might originally guess. So let's just check the rule. We need to do a squared times the variance of x plus b squared times the variance of y. This is always a plus in the middle. So I have got a 2, so I need to do 2 squared times the variance of x plus 3 squared times the variance of y. Even though this is a minus, I always get a plus in the middle here. So I need to do 2 squared, which is 4, times the variance of x, which was, variance of x was 4, so it's 4 times 4, okay? 2 squared times the variance of x. Then I need to do plus, okay, 3 squared, which is 9, times the variance of y. What was the variance of y? It was that, 9 as well, okay, all the square numbers. Okay, so 4 times 4 plus 9 times 9 is 16 plus 81. 81, not 18. 16 plus 18 is 81 equals 97. Okay, so therefore 2x minus 3y, well, its distribution is normal with mean minus 55 and variance 97. But I need to state the mean, which is minus 55, and I need to state the variance, the standard deviation. Okay, and the standard deviation sigma is not 97, it's the square root of 97. Okay, all right, one more to do. Okay, I think we're getting the hang of this now. So this last one, okay, I want the expectation of minus 5x minus y. Expectation works how we'd expect. So this is minus 5 times the expectation of x minus the expectation of y. The expectation of x was 10, so this is minus 5 times 10. The expectation of y is just 25, so it's minus 5 times 10 minus 25, which is minus 75. Okay, all right, and the variance of minus 5x minus y, that should be a capital X, okay, equals minus 5 squared, okay, times the expectation of, sorry, not the variance of x, okay, plus, it's always a plus in the middle, even if this is a minus, the variance of y, okay? So this is minus 5 squared, but remember, when you square a minus, you get a plus number, okay? All right, if you did this wrong, you'd end up getting a negative value for the variance, and you know that's wrong. We can have negative values for means, okay? So that happened to us all over the place, but we never get a negative value for variance or for standard deviation, okay? So if you accidentally got a minus 25 here, okay, you'd recognize your mistake later, all right? But we're not going to make that mistake. So minus 5 squared is plus 25. And then the for the variance of x, okay, what was the variance of x? It wasn't that 2, it was this 4. So 25 times 4 plus just the variance of y, which was this 9 here, so plus 9, so that's 109. So I've got my random variable minus 5x minus y, and its distribution is normal with a mean of minus 75 and a variance of 109. Okay, so mu equals minus 75, but its standard deviation is the square root of 109. So that is how, if you're a little bit neater than me, I hope, okay, that is how to set up means and standard deviations and distributions of independent combinations of normal distributions. Okay, so yes, enjoy.